So we're starting a new unit and we're working on number systems, which is what the NS stands for. So the standard is ARCH.7.N.S.A.1.7.2a. The learning target is I can add, subtract, multiply, and divide fractions. So remember, when we define fraction, we say a fraction has a numerator and denominator. The numerator is part of the amount in which the denominator represents the whole amount. So the numerator is the top number, the denominator is the bottom number. For example, 4 out of 10 students were wearing sweaters. So we write the fraction 4 students out of 10 students, 4 over 10. First, when we add fractions, we must keep in mind that denominators must be the same number. Example, 2/3 plus 4/3 equals 6/3. Do not add denominators. Together. So you're only adding numerators. 2 plus 4 equals 6, and then the 3 stays the same. So 6 over 3 can be reduced. 6 over 3 can be put into your calculator as 6 divided by 3, which equals 2. But to prove it to yourself, you can double check your work, and divide both the numerator and the denominator by the same number. 6 divided by 3 is 2, 3 divided by 3 is 1, which it is in fact 2. So before we move on to the next example, we must understand how to multiply fractions. So you must multiply the numerator times the numerator. You must multiply denominator times denominator when multiplying fractions. For example, 2/5 times 3/4 equals, multiply the numerator times the numerator, 2 times 3 equals 6. Denominator times denominator, 5 times 4 equals 20. So can you reduce? Well, immediately if you see that those are both even numbers, you can at least reduce it by a factor of 2. So 6 divided by 2 is 3, 20 divided by 2 is 10, and that is your final solution. Another example, find the product. 2/3 times 1/5. Notice how I took the x now and used a dot for multiplication. But you still go across. 2 times 1 equals 2, 3 times 5 equals 15, and that is your solution, 2 over 15. The next example reminds you that when the word of is used, as in 2/3 of 15, it signifies multiplication. 2/3 times 15 over 1, anytime you have a number without a denominator, you're going to use 1 in the denominator. So multiply across numerators. 2 times 15 is 30. 3 times 1 is 3. Can 30 divided by 3 be reduced? Yes, they can both be divided by 3. 30 divided by 3 equals 10. 3 divided by 3 equals 1. So 10 over 1 is your solution, which can also be written as 10. Another example, 1/3 times 1/4 times 2/5. Now we have 3 fractions, but you still multiply across. 1 times 1 times 2 equals 2. 3 times 4 times 5 equals 60. You can see they're both even numbers, so they can be reduced. Here 2 can be reduced by itself. 2 divided by 2 equals 1. So 60 needs to be divided by 2, which equals 30. 1 over 30 is the final answer. So going back to adding fractions, we have an example which will require you to multiply. And that's why I just taught multiplying fractions. Because when you have two fractions that are being added, you must get a common denominator. And the way to do that is through multiplication. Since 3 and 7 are not the same, multiply each fraction so that they have a common denominator. 2/3 can be multiplied by 7/7 because 7/7 also equals 1, and it doesn't change the value of the fraction here. And 5/7 can be multiplied by 3/3 because it also represents the number 1 and it doesn't change the value of this fraction. So what happens when you multiply across the numerator? 2 times 7 equals 14. 3 times 7 equals 21. Now remember, you're still adding these two fractions, so you need the plus sign. 5 times 3 equals 15. 7 times 3 equals 21. We did that so that we could have a common denominator, so that now we're allowed to add the fractions. So remember, you add the numerators. 14 plus 15 equals 29. And when you're adding fractions, you leave the denominator the same. 29/21 is a correct answer, but it can be turned into a mixed number by remembering that 21/21 is the number 1, and 8/21 is your leftovers, because 21 plus 8 equals 29. 21 stays the same, so 29/21 is the same thing as 1 and 8/21. And that's a mixed number, which is also a correct answer. Now we're going to subtract fractions. The denominators must be the same number, just as in adding fractions. For example, 4/4 minus 3/4. You subtract the numerators. 4 minus 3 equals 1, and you leave the denominator the same. Subtract the numerators, leave the denominator alone. Example, step 1. If denominators are not the same, multiply the denominators to achieve this. So just as we did in adding fractions with different denominators, we need to find a common denominator. So what is common between 3 and 8? Since 8 times 3 equals 24, use this strategy to get a common denominator. You can multiply the denominators by each other. And since you want to get 24 as a common denominator, you'll multiply this fraction by 3/3 and this fraction by 8/8. This way you can see in advance that you're going to get 24 as a common denominator. Now you need to multiply the numerators of each fraction. 7 times 3 equals 21, minus, don't forget the minus sign, 2 times 8 equals 16. Leave that 24. Now 21, take away 16 equals 5. The 24 stays the same, and that's your solution. Finally, when we go to dividing fractions, we have a strategy. To divide is the same thing as multiply by the reciprocal. Define reciprocal, the inverted fraction. In other words, flip it. Example, 2/3. The reciprocal is 3/2. So when dividing fractions, for example, 2/3 divided by 3/4, you follow these steps. Step 1. Multiply both the numerator and denominator by the reciprocal of the denominator. So 2/3 over 3/4. Each one of these gets multiplied by the reciprocal. that way, you can see that the denominator will turn into the number 1, and the numerator has to be multiplied, the fraction still has to be multiplied as numerator times numerator. So 2 times 4 equals 8. 3 times 3 equals 9. This is 12 over 12, which is the same thing as 1. So you have 8/9 over 1, which is equal to 8/9. So remember that any number that is the same as itself in the denominator, when the numerator and denominator are the same, it equals the number 1. And therefore, it won't change the value of the numbers that you're working with. That is the end of this lesson.